Okay, so we want to know how fast is his distance from second base decreasing when he's halfway to first. So his distance from second base, here's our little guy running, right? And he's running this way, and his distance from second base is that distance there. And this is what we want to know. And they tell us a little bit, and I see I kind of want to work with this triangle here. So I'm going to call his distance from first base y, because that's changing. And what we want to find is how fast his distance from second base is, so how fast, that's a rate, dx dt, when he's halfway to first base, so basically when y is 45, half that distance there. And they tell us a little bit, they tell us his speed, he's running towards first base with a speed of 24 feet per second. So this little distance is changing at 45 feet per second. So, if dy dt is 45, it's actually going to be a negative 45 because that distance is clearly getting smaller as he runs towards it. So now we have what we want. We've kind of translated the problem, and a lot of times in these problems we're working with right triangles, and right triangles you can relate to all the pieces with Pythagorean theorem. So a squared plus b squared equals c squared, so y squared plus 90 squared equals x squared. Now we need derivatives, so go ahead and take the derivative implicitly. So 2y dy dt plus the derivative of 90 squared is just a constant, so that's 0, equals 2x dx dt. And I'd like to find dx dt, so if I solve for that, I can just divide both sides by 2x. So dx dt is going to end up being, well, the 2's cancel out. So it's just going to be dy, I can write y dy dt divided by the x. So just divide both sides by x and you'll solve for dx dt. And that's what we want to find. We want to find dx dt, so let's just plug stuff in. I know y, at the particular moment we want, is supposed to be 45. I know dy dt is negative 45. And I know x, I don't know x, but that's okay. I can find x at that particular moment because I know that at this particular moment y is 45. So using my same setup, I can say that when y is 45, I'll have 45 squared plus 90 squared will be x squared. And if I solve that, I've got 45 squared plus 90 squared is 10125. So 10125 is x squared, so x is going to be the square root of that nasty mess. And I don't think that's anything pretty. I could simplify it. Don't really feel like that now. So we're just going to plug it in straight into here like that. And that is your answer. If you want to clean this mess up, we'll go ahead and simplify this guy. Square root 10125. Nothing nice. I can take 10125, divide it by 5. I get 2025, divide by 5 again. I get 405, divide by 5 again. I get 81, which is a 9 and a 9. So this square root simplifies to 45 root 5. And that's nice because my top is 45 times negative 45. So those 45's cancel out. That actually ends up pretty nice. So negative 45 over root 5. And if you must, go ahead and rationalize that denominator. Negative 45 root 5 over 5. So negative 9 root 5. and that is how fast that length is decreasing at that particular moment. Sweet.